Welcome everyone to my course Formal Methods for System Verification. In today's class, we will learn preprocessing of SAT formula. In the previous week, we have learned how the SAT solver works. We have learned the DPLL algorithm, the implication graph, clause learning, CDCL, everything, right? And the previous class, we have learned about different decision heuristic. In the sense, when you do the SAT solving, you have to decide which variable you will pick and which value you will pick, right? And then finally, that will actually determine how your overall SAT goes, right? In continuation of that, in today's class, we will learn the preprocessing of SAT formula. As you know, that SAT formula has set of clauses. It's basically in CNF format, right? And to make the formula true, you need to make all clauses true, right? If you think about a formula F, which is C1 and C2 and C3 and C4. So, to make this formula true, you need to make each individual clause true, right? And within the clause, you have disjunction of the literal, right? It may be say x1 or x2 or not of x3. This is a C1, C2 is something x2 or x3 or not of x4 and so on, right? So, what you have seen that since you have to make all clauses true, if the number of clauses you can reduce, that will actually impact the overall runtime of the SAT formula, right. So, if you are initially you try to see is there any clause which is redundant, right, that is the preprocessing will do. On the other hand, we have also seen that the smaller clause actually useful, because if you have a, say x1 or x2, if you know the value of x2, we can do the unit propagation and you can easily get the value of x1, right. So, the shorter clause are actually better, that actually can take a fast decision, or I can conclude about the shorter clause quickly, because it has less number of literals. So, even if I have a bigger clause and I identify some of the literal, I can actually remove, they do not actually participate in the actual SAT formulations, we can actually remove those literal as well, right. So, we can also reduce the number of literal in a clause. So, the preprocessing that we are going to discuss today is effectively given an initial formula, because the formula is capturing certain thing, right. So, it may be checking equivalence of two circuits, it can be checking something else, right. It can be a scheduling problem, it can be seating arrangement problem, anything else. So, the point here is that when you generate the formula, it just captures the context, but many of these clause may be redundant, you do not need them, or some of the literal within the clause may be redundant, right. In context of the SAT solving, we can actually take easy decision about those cases. So, preprocessing steps is actually looking for those scenarios and try to reduce the size of the clauses by removing the literal and also removing the clauses. So, overall formula size reduction is the primary objective. Okay. Before going into this all preprocessing kind of operation that you can perform, I will just briefly introduce how do you encode the SAT formula for any practical SAT solvers, right. So, you have many SAT solvers available academic community, you can just use them, but to have the CNF formula you need to first encode them in their format, so that it can work on that, and that format is very simple, it is called DIMACS format. So, how it is the format is like that, you basically say this is a propositional formula, then you say the key propositional formula is in CNF format, how many variables are there in your formula and how many clauses are there in your formula, and then for you describe each clause one by one. Okay. I will explain that, and each clause will be n by 0. Okay. So, we effectively encode the entire formula using integer only. So, what we can do, each variable I can actually add an index, right. Let us take the formula I have say F here, which has 3 clauses C1, C2 and C3. So, this is my C1, this is C2 and C3. I want to encode this in DIMACS format. So, I just assume that my x1 is say 1, x2 is 2, x3 is 3 and x4 is 4. Okay. This is thus giving index of each variable. Then, because I have the formula is in P CNF, there are 4 variable x1, x2, x3, 4. So, I just put 4 and 3 clauses. So, I put 3. Now, I have to encode this clause C1, right. So, C1 has x1. So, I can just write 1 here, because x1 is 1, it has x2 which is 2 in my encoding, it has x3, so it has 3 and then 0. So, it effectively, this effectively means x1 or x2 or x3, right. Now, the clause 2, it has x2, so I will write 2 here, it has negation of x3. So, a negation of x3 we just write minus 3, we just add a minus in front, it just represent the negation of the literal, okay, and it has 0. So, this is effectively represent x2 or not x3. Similarly, C3 has x4 minus negation of x2, negation of x1. So, we usually use it in a normal form, in the proper order of the variable we maintain. So, x1 always come first. So, this is minus 1, then minus x2. So, minus 2 is for negation of x2 and x4 is 4 by 4 is 0. So, this is effectively means not of x1 or not of x2 or x4, right. So, this is how I can actually encode the entire formula, and it reads and internally store the information and then start processing, right. So, to use SAT solver, you should convert your things into this format. So, on the pre-processing we will learn few of the techniques. The techniques are mostly very simple. We will learn tautology elimination, we will learn unit clause assignment, we will learn pure literal elimination, subsumptions, self-subsumption or strengthening, blocked clause elimination and vivification. There are 7 techniques we will learn, but they are quite easy to understand. So, we will start with tautology elimination. So, you know what is tautology, right. So, if you have a formula which is tautology, means it is true for every possible input, right. So, tautology is basically a formula, f is tautology if it is true for all possible inputs, right. So, now we are concerned about the clauses and the formula. So, we will basically try to see whether any of the clause is tautology. So, when a clause can be tautology, if that particular clause consider x, say for example, some variable x, it contains both x and not x, right. So, give an example here. Here I have x1 or x2 or x3 and not x1. You see here you have x1 also present, not of x1 is also present. So, this clause is a tautology. Why? Because if you consider, because it is a disjunction of the literals, right. So, if any of them is true, the clause will be true, right. So, now think about x1 is true. So, x1 is true means this is true, and since this is true, the entire clause is true. Now, assume that x1 is false. So, then not of x1 is true. Since not of x1 is true, the entire clause is true. So, the no matter what is the value of x1, whether true or false, this clause will be true. So, this is tautology, right. So, what we can do, we can just see is there any clause which is a tautology. It means it contains both actual variable and its negation inside the same clause, then you can just remove this. So, when you implement this kind of optimization, you have to just think about the complexity also. So, what you can do, you can take each clause and search for this. So, it is effectively order of n, right. You basically search the entire clause, or if you basically look into this DIMACS format, you will have 1 minus 1, right. So, you basically have 2 minus 2 kind of point here. So, you can just scan this CNF formula here and you will just see whether you have 2 minus 2 or 1 minus 1 kind of literals inside that, right. If you have, you just remove that particular clause, okay. So, this is very simple. Unit clause is also a very simple idea. So, you know what is in unit clause, right. It means it has only one literal, right. So, a clause consists one literal, and now if you have a particular clause has one literal, what does it mean? It means it has only one possible value it can take, right. So, for example, I have a clause say C which has x1. So, your x1 has to be true, otherwise this clause will be false. Or let us say I have another clause which is not of x4, then x4 must be false, x4 must be false, otherwise this clause will be false, right. So, if I have a unit clause, I can just remove that because it can take only one value. So, I will just assign that value to that variable and remove that, but it has also have some advantage, right. Say for example, I have say this formula C which we have 3 clauses, right. The first clause is x1, next one is this, and this is C3, right. Now, this is the unit clause, and this x1 must be true, because otherwise this clause will be false. But this x1 can also occur in other places or other clauses. So, I will assign the value of this x1 the true to all places, and that will also reduce the size of the clauses, other clauses as well, right. So, you are not only removing the unit clause which has a single literal, you also push that value or propagate the value that it is taking to the other clauses, so that the other clause size also can get reduced, right. Just to give an example here. So, I have x1 which is true, then I found that in C3 I have not of x1, so which is basically false, and then if it is false, x4 must be true, right. So, this C3 now reduced to x4, because I have assigned the value of x1 is true, so not of x1 is false, which is removed from this clause, right. So, then I am actually reduce the size of the clause C3 as well. Now, this also become unit clause now, right. So, this value must be true, right, because otherwise this C3 will be false. So, I have already got the value of x1 and x4 before starting the SAT solving, right, just by doing unit clause assignment. So, effectively initial formula has 3 clauses, now 2 clauses already get satisfied, my reduced formula has only 1 clause, which is C2 only, right. So, this is how it actually helps. It is not only assign the value of the current literal, by propagating you are impacting the other clauses, that may open up the options of another unit clause, and this can also be propagated further, right. So, this is how you can think of this. Again, in terms of the complexity, it is basically you have each clauses, you identify the unit clause and you see what is the occurrence of other, that literal in other, you simplify them, and then this also can open up, right. So, one literal searching is order of n, right, because you have to search the entire formula, and this can have do k times, because you just take one variable that is propagated, that will open up new options like x4, that will also be propagated, but this is a fixed number of times, maybe 2 times, 3 times and 4 times, right. So, something like this. So, effectively it is order of n complexity, where n is the size of the formula. Now, we will learn pure literal elimination. So, let us understand what is pure literal. So, a particular literal is called pure literal in a formula if it only occurs either in the form of x in all clauses or wherever it occurs, or as a not L in the clauses where it occurs, right. So, it does not have both L and not L in your formula, right. So, either only literal L or not L occurs in all clauses, and both of them does not occur. Okay. It is not necessary that the clause has to occur in all clauses. It means that if there is a 5 clauses, 2 of them contain L, but there is no clause that contain not L, right. So, then this L will be considered as pure literal, right. So, what we are saying that since this can take only one value, right, you can actually assign that value and you remove that from all clauses, right, because pure literal has only in one kind of occurrence, either L or not L. So, to make that particular clause true, you have to assign corresponding the value, right. If L is occurring there, you have to assign true. If not of L occurring there, you have to assign false, right. And you can assign every places and remove that particular literal from the all clauses. So, by doing that, what you have done, for one variable you already get the assignment, and it also impact all the clauses where it occurs, reduce their size also, right. So, it has a double advantage. So, to give an example, let us say I have a formula F which has 3 clauses, right. This is a C1, this is C2, this is C3, and let us check what are the literals are pure literal. If you see here, if you see A occurring in this clause, in this occurrence, there is no A here, and you have only A, right. So, A is a pure literal. Does C is a pure literal? Let us check. C occurs here as C, but C occurs as a not C. So, C is not a literal, pure literal, because both C and not C both present there, right. Is B is a pure literal? It is no, because not of B present here, B present here, it is not a pure literal. Again, you can ask whether D is a pure literal, it is not, because D occurs here, not of D occurs here. So, both instances of D and not D occurs in some clauses, so they are not pure literal. So, in my example there is only A is pure literal, okay, and A, because A occurs here, so A must be true, right. So, if I put true here, this particular clause is true, this particular clause is true, or this becomes satisfied, right, because it is a disjunction of literal. So, effectively just identifying this pure literal and assigning the value to that clause where it occurs, that particular clause will automatically become true, right, because that contains only disjunction of the literals. So, effectively all the clause where that particular pure literal occurs, that will be also removed. That is a good advantage, right. So, effectively initially I have formula as 3 clauses. By just identifying that A is a pure literal, I can remove C1 and C2 because they will become true if I assign A equal to true. So, the reduced formula will be only consist of C3, one clause, right. So, this is the advantage, and in all cases this is kind of equisatisfiable because you already assign the value of A, and then this new formula will also be, if it is satisfiable, if and only if the original form is also satisfiable. So, this is again very advantageous because it is not only removing the literal from the clauses, it is actually removing many clauses from the formula. Each pure literal will remove few clauses, right. So, if you identify say 2 or 3 pure literal, that will impact significantly on the size of the SAT formula. Okay. Now, I will move on to subsumption. This is another optimization. Let us get the definition of subsumption first. It is effectively subset of a clause, right. You have 2 clauses. Is one clause is a subset of the another clause or not, right. And how do you mean by subset? If all literal occurring here is also occurring there, right, it can happen. So, then I will say this particular clause is subset of the other clause, right. So, in definition, clause C2 is a subset of C1, which is basically C2 subset of C1 if all literal that present in C2 also present in C1. Very simple definition, right. But what is we can take in this scenario? So, I have 2 clauses, right. Let us take an example. Say suppose I have a formula which has 4 clauses C1, C2, C3, C4, and let us say C1 is this and C2 is this. You can see here this C2 is subset of C1 because x1 occurs here, x1 occurs there, x3 occurs here, x3 occurs here, x4 occurs here, x4 occurs here. So, all literal that present in C2 also present in C1. So, C2 is subset of C1. Here the question is that they are very clear that there is overlap, right. So, which clause I can remove here? Should I remove C1 or should I remove C2? The answer to the question is you should remove the bigger clause C1. You remove C1, you keep C2 here. Why? Because this has less literal, this has more literal, right. If by any chance you make this formula true, right, by some assignment, say you put x1 equal to true, x3 equal to false, x4 equal to false. Say because of some SAT solving you get this assignment. So, that will make this C2 true, and because this is subset of this bigger one, this will also be true because the other literal are there, I do not care about them, they are redundant, because if these 3 can decide this clause, I do not need to think about the other literals, right. So, if I identify this subset, I will always remove the bigger clauses, not the smaller one, right. So, that is what this subsumption says, that in such case if C2 is a subset of C1, this clause C1 can be eliminated, not the C2, right, and it is quite understood. Again, in terms of complexity, you think about it is in DIMACS format and it is a pattern, right. So, I get this one sequence this of integers, right. So, for example, if you have this x1, x2, x3, x4 and say their index is say 1, 2, 3, 4. So, this will be represented as like 1, 2, 3, 4, 0, and this is your C1 and C2 will be represented like 1, 3, 4, right, 0. So, if you have this, I can actually just say whether a particular string is subset of another string or not, right. In this way you can actually cross check and you can identify. So, it is effectively if you try to identify between 2, for each such clause you have to check other one, right. It is kind of order of n square complexity to identify whether a particular clause is subset of another clause, okay. In high level there may be some efficient implementation. So, this will also reduce the number of clauses, right. We are actually removing some clause from the actual SAT formula. Okay. Next we will learn self-subsumption or strengthening. This is also kind of a case where I can remove some literal from a clause, not the entire clause. Okay. So, let us consider the scenario. Let us say I have a formula where I have two clauses C1 and C2. I have C1 and C2, and look at the formula structure. It has some literal x and a sub formula a. A is not a single variable. This may be say y or z, right. So, some sub formula, but it has x as a literal, and I identify another C2 which has not x, right. So, I will identify, I will only consider those C2 which has not x first of all, okay, and also this a present there, whatever the sub formula, the disjunction of literal, that also present there. Okay. So, this is basically y or z. It also may have something else. Okay. So, this may be say p or q. So, effectively I am saying that C1 is a formula which is x or y or z, and C2 is a clause which is p or q or x or y, not of x or y or z. This is the scenario. So, if there are two such clauses where if you have x here, not of x here, and the rest of the formula also present here, but it may also have something else. If this is the scenario, we can remove x not of x2 from C2. So, we are not saying that we are going to remove the entire clause C2, we are only saying that not of x can be removed from C2. So, in this case my resultant formula will have C1 plus C2, which is C2 dash, which will be p or q or y or z. So, this will be removed from this. Okay. So, the question is why this can be done. Now, look it carefully. If I do a binary clause, binary resolution on these two formula, you remember what is binary resolution, right. So, if you have a formula say f, whatever, you have two clauses. So, suppose the clause has, let me write it properly. So, if you have say x or y or z, right, x or y or z, and another clause you have x or p or not of z, right. You have two clauses. So, if I do a binary resolution against z, because z is present here, not of z present here, the resultant formula will be x or y or p, right. So, because x is common here. So, this is the resultant clause. Okay. So, this clause is a combination of the rest of the literal. Now, if I apply this binary clause resolution here, what will happen if I do this C1 and C2, that C1 and C2 that I am taking, if I do this, because A is common here and B is common here. So, not of x will go and the resultant clause will be A or B, right, whatever A and whatever B. So, if you take my example here, it will effectively generate this resultant clause, right, if I do a binary clause resolution here. So, this is my A and this is my, sorry, this is my B and this is my A, right. So, this is how I am getting this. So, I am keeping this clause and I am effectively removing this clause, right. But if you recollect the SAT solver based on the binary clause resolution, we say that if we keep applying the binary clause resolution, and if I able to get a scenario where I get an assignment, I will say that this is correct, or if I get a contradiction, then I will say this is not satisfiable, right. So, that kind of SAT solver we have defined. But we have also discussed there that we do not get the assignment of the values actually, right. We just keep applying binary clause resolution, but we do not get the assignment. But in SAT solver, we want to do not only say that whether the formula is SAT or not, but we also try to see whether the formula is, what is the value under which the formula is true. So, here just to keep that, we will also keep C1, right. So, only thing is that we are keeping the resolvent clause, the new clause that we do get by this binary clause resolution, and also will keep C1, right, just to make sure that we will actually get the assignment. In binary clause resolution, if we just keep applying that, we will lose the context and we will not get the actual assignment. So, to keep that, we will remove this C2 and whatever the new clause we learn, that will I will keep, and also I will keep C1, right. That is what self subsumption or strengthening. So, effectively we are strengthening the clause C2 by removing some of the literal which is redundant, right. So, effectively this resolve and subsume one of the parent clauses, the C2 that I talked about. Just to give one more same example, suppose I have two clause C1 and C2, and C1 is this and C2 is this, and say here my that literal is W, right. So, I have not of W here, W here, and A is basically Z, right. So, this is my sub formula which is present there, and this also have something else which is B, right. So, that means if I do a binary resolution here, by this I will get a formula which is X or Y or Z, right, W will go out. So, this I will keep C2 dash, and this is C1 dash, and C1 I will remove, right. So, this is what my idea, right. I will keep C2 as it is, and I will, this is the new clause I learned from by doing a binary clause resolution. So, I will keep that, but I will remove C1 from this, okay. And many of the SAT solver does this kind of optimization. So, again this is clause level analysis. So, it is kind of order of n square you can think about in high level, right, to identify whether this particular scenario occurs or not between two clause. Okay. The next one is block clause elimination. So, what we are saying that is there any clause which is blocked, right, and if that particular clause is blocked, you can remove this. So, let us define what is blocked clause. So, it says that a clause is blocked if resolving it on a certain literal always produce a tautology. Tautology we have already discussed, that means the resultant clause is always true. Okay. So, now let us see what is the definition of this block clause elimination. So, this precisely define this. So, what is saying that since I have a clause say C, okay, and this C is block clause. So, I will try to see what is this C. Okay. It says that if there is a literal L, so I have a literal L in this C which is called blocking literal, such that for each other clauses where not of L present, let us say I have another clause, say this is C1, this is C4 and there is a C5. Okay. So, if L present here, not of L present here, there may be 100 clauses, but only the clauses where not of L present, I will only consider those clauses, right. So, I identify that L present here and C4 and C5 where not of L present. Okay. So, I will only bother about these three clauses now. Now, for each such clauses, the C4 and C5 where not of L present, there is a literal LK in C such that not of LK present in this C dash, right. This is a clause. So, this is basically OR. So, what I am saying here, I have L present here and not of L present here, I identify two such clauses. Then I am saying that for all such cases, there are some variables say x4 present here and not of x4 present here. It may be that you have not of x2 present here and x2 present here, and you have something else also, and it has something else. So, if this is the scenario, right, I am saying this is a blocked clause and this is the blocking literal, and I will remove this clause. Okay. So, let me explain again. So, what I am saying here, if for some literal L, I will identify which is present in a clause, all the clause where I will identify not of L present, I will identify such clauses, and then also I found out that in all those cases there is also a literal LK which present here and not of LK present here, and it not necessarily the same variable, right. So, x4 present here, not of x4 present here, not of x2 present here and x2 present here. So, then I will say this is a block clause and I can remove this. Okay. Why I can do that? Let us take an example first. Okay. Let us say I have clause C, this is my C1, this is my C2 and this is my C3. Let us say this is my clause, I am checking whether C2 is blocked clause or not. Okay. Is C2 a blocked clause? So, I will identify the variable, let us say my L is A, right. So, I have A here, I will identify all the clauses where not of A present, and that is the clause C3 because not of A present here. So, I have C2 which has A or not B or not C, and I have C3 where I have not of A and C. Now, also I found that there exists another literal not C, right, literal not C. So, not C present here and C present here, right. So, then all the clauses satisfied. So, this is a block clause, yes. So, this is a block clause and you can remove C2, right. So, I will only keep this C1 and C3 in my final clause. So, I can remove C2 from here. Okay. Now, it looks quite not so obvious, right, why I can remove C2. Let us see why this can be done. So, what I have said that this is my C1 and this is my, so this is my C2 and this is my C3 in my example, previous example, right. So, I just copy this is my C2 and this is C3. So, this is C2 and this is C3. If I do apply binary clause resolution on A, right. So, A and not A present here. So, they will be removed and the resultant clause will have this and this, right. So, it will basically have not B, not C and C, and see this is a tautology. Why? Because of C. What I told that it also have another variable where L and not L present there, right, LK and not KL present there. So, when I combine these two such clause, it will always result in a tautology, right. So, that is why I can remove that clause C2, right. So, that is what I talked about, that I can remove the block clause because if I combine this clause with the other clause where which actually have this LK and not KL kind of thing, the resultant clause will be always tautology. That means which is always true. So, that means this clause has this clause, that clause which has the blocking literal is not contributing to the actual decision, I can remove them, right. So, this is what effectively the case. So, I can, if I ask the question is not C is a blocking literal, it is always true because you have the pair here, you have here A and not A can be blocking literal and C also, because if I say consider not C here and C here, and in that case if this C is a blocking literal, then I identify the pair A and not A, right, which actually causing this as a blocking literal. So, yes, this I can consider C also as a blocking literal, and in that case A is the that LK variable, right. But if I ask is C1 is a block clause, let us check. So, it has A and in this clause you have not A. So, now I have to identify whether it has C, whether not C here, no, right. So, that means this A is not a blocking literal in C1. If I now consider B, so B has here and not B here. So, that means this can be a potential clause that can make it blocking literal, blocking clause, but it has A and not C, right, but it does not have not A or C here. So, I cannot say that this B is blocking this. So, C1 is not a blocked clause. Okay. So, we cannot remove C1 by using blocked clause elimination. Again, in the complexity wise is basically comparing between two clause. I can think about in a high level the complexity will be around n square. Okay. The last one is called vivification, it is very simple, and this effectively check in a particular clause a particular literal is redundant or not. Okay. So, how it is effectively been done? It use the unit propagation, okay, and I will explain why, how it is happening. Let us say I have a clause, it is a generic clause which has say n literal, and I want to check whether a particular literal Li is useful here or redundant. Okay. So, what it does, you remember this is basically part of the formula. The formula may have any other clauses. Okay. This is one of the clause in the formula. So, what we will do in that formula which may have say 10 clauses, this is one of them, I will add this many new clauses, okay, which is basically the negation of the literal that presents here except Li. Okay. So, I have L1 here, so I add a new clause not of L1, it is a unit clause. L2 is there, I add a new clause not of L2, unit clause, and so on. I have for Li minus 1 not of L minus 1, Li plus 1 not of Li plus 1, but there is no not of Li. So, I am not putting negation of Li here, and till I have till Ln, so I have not of Ln. Okay. So, this is the unit clauses that I add to this. So, what is the impact of this? This particular clause may have any other clauses, and these are the unit clause. So, they will propagate to the other clauses and something will happen there. Okay. And there are many such scenario can happen. So, let us say the formula has, I have the C, that is my the clause that I am thinking about, then you have say C2 to say C10, right. So, these are the other clauses, and I have added all this negation of this, right. So, not of L1 to not of Ln. So, these are the unit clause that I have added. So, what I am going to check, what is the impact of this in these other clauses, okay. And there are 4 scenarios can happen. The first scenario is that kind of no conclusion. In the sense, these clauses may have many other variables other than this L1 to Ln, and they are not reduced to true or false or contradiction, right. So, in that case, what I will say, this particular literal Li I cannot remove here. I cannot conclude whether I should remove this Li from this clause or not, because it's there is no conclusive decision. Okay. Now, second thing can happen that this particular literal propagates here, and I reach to a situation of contradiction. Remember, I am just talking about the other clauses, not C. I am not talking about C where Li presents, because I am just checking whether Li is useful inside C or not. Now, if you have a contradiction, what does it mean? I have taken the negation of this literal and I reach a contradiction. What does it mean? This particular decision of these literals is wrong, right. So, that means some of the things are wrong. So, we cannot get the satisfactority of the rest of the clauses with this. Hence, again I cannot take any conclusion about my literal Li, because my objective here whether this Li is useful or not. So, in this case also not remove Li, right. So, not remove Li from C. So, here also the same decision, because I cannot conclude anything. Third scenario, that these clauses reduce to Li, right. So, because I have added not of L1 to not of Ln, not for Li, and they are these clauses are such that these literals are present there, and because of the unit propagation they are got reduced to Li only. What does it mean? It means when I assume the value of this all L1, L2, L3, Ln minus 1, L plus 1 to Ln as false, the other formula reduced to C. So, which demands reduced to Li. That means, it demands that if Li equal to true, then this rest of the formula will be true. Okay. And if you notice here, because I have taken the negation of L1, negation of L2 and all, if I do the unit propagation, this clause C will also reduce to Li. That means, in this clause all other clauses are false, all other literals are false except Li. So, Li must has to be true, right, then only this clause will be true. And rest of the clause also saying the same thing, that rest of the clause also will reduce to Li. So, that means, if Li is true, then the rest of the clause will also be true. So, that means, Li is here is important. Again, you cannot remove Li from C. Okay. So, all these 3 scenarios you cannot remove Li from C. The fourth case, you reach that reduce to not of Li, right. So, that means, I have taken this C1 to Cn and I take this unit clauses and I put it here unit clause propagation, and these clause are reduced to not of Li, right. What does it mean? It means that to make this formula, rest of the formula to true, Li should be true, Li must be false, right. And as I also discussed that because this L1, L2 and this all other is false, to make C true, your Ly must be true, right. So, it is basically having a two different decisions. So, here your Li must be true, here you are saying ki Li must be false, then only this will be true. So, here I can conclude that Li is not needed in Ci, and hence you remove Li from C. Okay. So, why I am doing that? If you just think about that, here I have taken not of L1 and not of L2 to not of Li minus 1 and not of Li plus 1, no Li, till I have Ln, not of Ln. So, this implies not of Li, not of Li in the other clause, right. So, if you take this implication and it is equivalent to negation of this, right. So, this is not of this or not of Li, which is equivalent to L1 or L2 or Li minus 1 or Li plus 1 or Ln and or L not of Li, right. So, this is the new clause that I learned from this, right. In the original clause I have Li, right. So, this is the new clause I learned, and in the original clause C I have the same thing, but this is C is basically L1 or L2, then you have Li minus 1 or Li dot dot Ln and or Li, right. So, because here it is not of Li and this is Li. So, if you do the binary resolution of these two, I will get a clause which is without Li, right. So, I will get effectively C which is L1 or L2 to Li minus 1 or Li plus 1 dot dot Ln. So, if I do a binary clause resolution, this and this will go away, right, and the rest of the clause will come, which is same. So, that is why I got kind of a new clause where no Li, right. So, whenever I got a not Li from the rest of the clauses, right. So, this is the only cases where I can remove Li from the C. Okay. So, just to if I conclude how I am going to do, I will basically add negation of this other literal to the clause and then I will do the unit propagation, and if the unit propagation result in not Li in the other clauses, that means I got a conclusion that I can remove Li has no role in C and I can remove that. Okay. So, give a very small example, let us say I have the clause C which is A or B or C, and I want to check whether C is redundant here or not, and the formula has say other two clause which C1 and C2 is this. So, what I will do, I will take a negation of A, negation of B, right, and I will check whether if I propagate this here, what is the result. So, if you see here, if I put negation here, so this will reduce to D, this will propagate here and this will reduce to E. So, which is basically means D must be true, E must be true. So, the rest of the clause does not conclude to, it does not, what is the situation happen? It reduced to actually satisfiability, right. So, no conclusion is another scenario, or maybe the first scenario is that you got a SAT there, right. So, effectively what I did here, I got a SAT here for the other part of the clause. So, in this case also you cannot remove Li from C, right. So, this is what I got here. So, I got basically the value of D and E, and it is no conflict occurs here, or basically I would say it basically does not force to not C here. So, I cannot remove, right. Now, if I take the same example and I take the new clauses, these three clauses say C1, C2 and C3. Here again I want to check whether C is redundant here or not. Again I will take negation of A, negation of B, and I will try to propagate. So, if you propagate negation of A here, it will reduce to D, right. Now, if I take this D and propagate here, this will reduce to not C, right. So, effectively I reduce to not C, and this is that scenario, right. So, this is the scenario I got not of Li. So, if I get not of Li, I can remove this C from here, right. So, I can C can be removed in this case, and this will reduce to A or B. Okay. So, this is how vivification works. So, what I have learned in this particular session is that pre-processing is useful to reduce the number of clauses and number of literal within the clauses, and that actually impact lot of in the runtime of the SAT solver. So, key things we have learned like subsumption, self-strengthening, vivification and block clause elimination. So, in subsumption we remove the redundant clauses, self-subsumption we reduce the literal within the clauses, vivification again we remove redundant literal in the clauses, and block clause elimination remove the redundant clauses. Okay. So, with this I conclude today's class. Thank you.